So, what we're going to be discussing today is, like I said, a very similar topic to what we talked about so far in class. It's going to build off of some of the concepts we did yesterday. So we're still solving equations, all right? We're still building on top of what we've done before with combining like terms, some distribution property, and we're seeing little by little all these things start to stack up, right, and come full circle. We started learning the basic ideas, and now we're applying them to these equations. Well, yesterday, what we applied was the idea of combining like terms. We had variables, multiple variables on the same side, right? We talked about combining first and then going through our process, get rid of any addition, subtraction, multiplication, division, and then simplify. Well, today, instead of seeing variables on the same side of the equation, we're going to see variables on opposite sides of my equal sign, all right? And we're going to be able to go through and now solve equations where this is the case, okay? So the first one that we're going to look at, we're going to do the same thing as usual. We're going to do an example, kind of develop a list of steps for each question, and then apply that to another couple of examples. Sound good? So whenever I see this, all right, my main goal in all this is to get my variable by itself, all right? Well, if I have variables on both sides, it's going to be hard for me to get something by itself unless I move all of my variables to one side and all of my terms that don't have a variable to the other side, all right? So if I'm looking at this equation, all right, and I'm trying to get all of my variables to one side, what do you think I should do on either side here? So I need to get either 5x with this x or this here. You got an idea? What's that? Divide by x? Is that what you're saying? No, something different. What was the first thing you said? Okay, so if I subtract 36 though, won't I just get 36 back over here? So I still have a variable and a number on this side. So maybe let's not think about the constant term or doing any division or anything yet. How do, what do I know are like terms here? If I just look across, what can I combine? 5x and this x right here, right? So we're going to start by moving the x term to the other side, all right? And the reason for that is because we know it's a common term, we can combine them. So I'm going to start by taking this and adding x to both sides. Right? That's all right. Because what's going to happen to the negative x plus the x? It's going to go away, right? And then what's 5x plus x? 6x. So now what do I have? I have all my variables on one side. All of my constant terms are terms that do not have a variable on the other side. And then Isaiah, do you want to tell me what I have to do from here? So how would I solve for x? What do I have to do? Right, divide by 6 on both sides. And what's 36 divided by 6? 6. Good job. So you're going to see examples like this throughout your ALEKS assignment. When we continue on with equations, a lot of times variables will be on both sides. All right. And it's important that we know we have to get variables to one side, all the other terms to the other. Okay. So they should be on different sides of our equation, just like we've seen in our examples up to this point. Okay. So let's create a list of steps for what we've done so far. All right. The first thing that we did was what? So what was this step right here? What was the first thing I did? What's that? Not divide. We added the variable to the other side, right? Because our first step is to get variables on one side and the constant terms, so just numbers, on the other. All right. So it's important that we understand that that should be our first step. We get variables to one side, constant terms to the other. Any questions there? So then when we add, right, these are going to eliminate, but we combine like terms on this side, right, between the 5x and the positive x. So we're going to combine terms by addition or subtraction, right? So we had the 5x plus the x, so that's my combining term step. What did I do to get the variable by itself? So if I had 6x, what did I do on both sides? I didn't add. Divide, right? So you're going to multiply or divide to get the variable by itself. And then my last step is to simplify. And one thing that we should also incorporate is the check, right? We want to make sure that we have, in fact, the right answer. Well, if I were to go through and check this, what's 5 times 6? 30. What's 36 minus 6? 30. So I get 30 equals 30 on both sides. So I know that 6 is my solution. All right. So then this would be my final answer. Not only did I solve for it, but I've also gone through, simplified, and checked my answer as well. Okay. Any questions about the first example? Okay. Let's take a look at the second example. So if I want to get variables on one side, what should I do to start this equation? If I want to get all of my variables on one side. What do I have to do? What's that? Add 3x, right? The x stays. So add 3x on both sides. Good. Because what's going to happen with the negative 3x and the positive 3x? They're going to cancel. 5x is plus 3x is what? 8x. Nice job. Divide by 8 on both sides, not 8x. So just because we're trying to get rid of, right? We're trying to keep the variable there. So I divide by 8 on both sides. And I get x is equal to, well, it's 16 divided by 2, or 8. Just gave it away. Which is what? 2. Good. Any questions about that example? Everybody good? Last example, what do I have to do on both sides to start? You'll see that there's a pattern in this, right? Pretty much doing the same thing each time. If I'm trying to get my variables on one side, what do I have to do? Subtract 2x, right? And one thing I want to mention is that a lot of times it's easier to deal with positive numbers. So like here, it wouldn't make sense to subtract 5x and then subtract the 36. Now I'm starting to deal with negatives. Same thing over here. I wouldn't want to subtract 5x and make a negative sign in front of my x values. If I already have one by itself, just move the other term over there also, right? Start to think to move things away from this constant term. Well, what's going to happen with the 2x and the negative 2x? Cancel. What's 9x minus 2x? 7x. How do I get the x by itself? And what's 49 divided by 7? 7. Good. Any questions about that example or anything that we covered today with this mini lesson? Real quickly, if we were to go back and check each of these answers, what's 5 times 2? 10. What's 3 times 2? And what's 16 minus 6? So I have 10 equals 10 on both sides, so that's the right answer. On the left, on the, the right-hand side on this example, what's 9 times 7? That would be 7 times 7. What's 9 times 7? You can use a calculator if you need. $63. What's 2 times 7? 14. And what's 49 plus 14? 63. So you have 63 equals 63 on both sides. So then that's your final answer as well. All right. So just to recap, you get variables on one side, constant terms on the other, combine those terms, get rid of your coefficient, so the number in front of the variable by multiplying or dividing, and then simplify and check your answer. All right. Any questions about anything that we covered today? Okay.